Right, my dear children. Now in the earlier chapters, we discussed about several things related to the physical changes. And we have observed what kind of a change is a physical change. We conducted several experiments to get some more idea about the physical changes. And we discussed finally that state changes. If you take a state change, that a state change is going to be a physical change, as there are no new substances are getting created, right? So we discussed a vast area regarding to physical changes in our earlier chapters, and now we are about to discuss some things related to chemical changes. Right, so within this chapter we'll be discussing the nature of chemical changes, how we can identify a chemical change. I mean, like what kind of an evidence, right? Or what are the evidences to show that there is a chemical change, right? So like that way we'll be discussing several things. We'll be discussing several things and several information regarding the chemical changes. So first of all, to get to know what do you mean by a chemical change more accurately, you are given with an experiment. So here we are studying the nature of chemical changes, right? We'll be studying the nature of chemical changes. So you know that if you take a chemical change, in a chemical change, we already know that chemical change is a type of a change which new substances are getting created from initial substances. Here, formation of a new substance occurs by rearranging the atoms or rearranging the matter contained in initial substances, right? So by doing these experiments, we'll be providing several examples that are regarding to chemical changes and how we can identify these chemical changes. Right then, so let's move on to see the materials that we need in conducting this activity. So first of all, you're given with a powder like substance, given in here a white color powder like substance. Actually those things are like salt crystals, right? Salt powder or salt crystals. This is called lead nitrate, a special type of a chemical, lead nitrate. Lead nitrate powder or crystals, right? Here you can observe lead nitrate, a white color crystalline powder. Then we'll be needing a boiling tube, and here you will be needing a Bunsen burner, in order to heat the system. System means here we need to add some amount of lead nitrate into the boiling tube and we need to heat it by using the Bunsen burner, right? So here it's really simple. The way of conducting activity is very simple. What you have to do is you have to take a sample like 1 gram of, right, like 1 or 2 grams of lead nitrate into the boiling tube, and by using a forceps you have to heat it, right? You can use a forceps. I haven't mentioned the forceps thing in here, but you already know that when you are holding boiling tubes, in order to heat up, right, we have to use a forceps, right? Without the forceps we can't heat it, no, otherwise our hand would get burned. So therefore we have to use forceps in heating these things, right? So these are the materials, the main materials that you need, and plus you'll be needing a forceps to hold the boiling tube, right? So it's really simple. You measure 1 gram, like 1 or 2 grams of lead nitrate, You put it into the boiling tube and you heat it, then observe what kind of a thing is going to happen within the lead nitrate, right? So let's move on to write down the method of the experiment. So method is really simple. Take about 1 gram of lead nitrate. Take about 1 gram of lead nitrate into the boiling tube. Take about 1 gram of lead nitrate into the boiling tube. Then heat the boiling tube well and observe the changes. So it's really simple to conduct this activity. What you have to do, you have to take about 1 gram of lead nitrate into the boiling tube. Then after that, you have to heat the boiling tube very well and observe the changes. So if I'm going to use a figure, can draw and show like this. It's really simple. So I'll use a different color to indicate lead nitrate, and by using forceps, right, we have to use forceps in holding this thing like this. We have to heat it up, right? It's really simple. So if I'm going to mark out the materials, this is the forceps, right? Then Bunsen burner, and this is the final one, boiling tube with lead nitrate. Right. So this is the method of doing the activity, right? It's really simple activity. Only thing that you need to find is the type of chemical, the lead nitrate thing, and you have to heat it to get the necessary observations, right? So we'll head on to the lab and we'll heat this lead nitrate and we'll see what are our observations. Right, my dear children. Now, in this set of activities, we'll be observing like what kind of things, or what are the evidences that we can provide during a chemical change, right? So when a chemical change is going to occur, what sort of a thing will happen into the system and what kind of thing is going to emit from a system, right? By using those things, how we can say whether a chemical change has happened or not. So in the first step, or in the first activity, we'll be heating lead nitrate. So here PbNO3 and again within brackets you can observe there is 2. So this is the chemical formula, PbNO3 twice, lead nitrate. So we are going to heat up lead nitrate in this activity to observe what kind of thing or what will happen during a chemical change. How we can say whether a chemical change has happened or not. What are the evidences to show that there is a chemical change or not. So I'm going to use some amount of lead nitrate first, and I'm going to insert this lead nitrate into, so lead nitrate, going to I'll show the nature of lead nitrate. See, so this is a white color powder, lead nitrate. This is the nature of the lead nitrate. See, it's like salt, lead nitrate, right? So now I'm going to add this lead nitrate into my boiling tube, and I'm going to heat it down to see what are the observations. So I'll put this thing into the spoon. Right, so I have used small bit of lead nitrate because when I'm going to heat this thing, somewhat toxic gas is going to emit, right? So I'm heating just a small bit of a lead nitrate. So now I'm going to hold this by using the holder, and let's heat the system. Right, my dear children, now let's heat the system and let's observe what kind of a thing is going to emit when I'm going to heat this lead nitrate in the boiling tube. Right, now my dear children, I'm going to heat the system. Observe the changes very well. So let's get the observations. See, in this situation, some small bit of explosions can also be observed within the boiling tube. So we have to be careful when doing this experiment. Observe the changes very well. See, a gas is going to emit. Like a brownish color gas is going to emit. Right, you can observe now there is a brownish color gas, and now when we see the residue is somewhat like brownish color also. You can observe, right, like in the earlier case. Now once again I'll keep it in here. Now I'll use some lead nitrate by using this. So here, check the color of these two. See, it's been changed to a like yellow color substance, and you could clearly observe that. A brownish color gas was emitted, right? Means that new substances have been created. During the burning of lead nitrate, a new substance was created. A gas was emitted, a brownish color gas was emitted, and the container is also like reddish color or reddish yellow color, right? So in this situation, we can observe the formation of a gas, right? A formation of a gas could be observed. Clearly observed, we could observe clearly there was a gas which is emitting when I'm going to heat the lead nitrate. So the first evidence in a chemical change is that if a gas is going to emit during mixing of two substances or when burning or any other cases, in that situation, a chemical change has happened. So that's why new substances or new gases are getting produced. So in this activity, it's obvious to us that lead nitrate has converted into, or it has undergone a chemical change and to produce a gas. Right, now let's continue with another activity, another experiment to observe what are the other evidences so that we can say in a given system a chemical change has occurred. Right, so we'll continue with the other experiments and we'll see what are the other evidences. Right, my dear children, so we conducted the activity and you could observe that, right? When I'm going to heat lead nitrate in the system of boiling tube, you could observe several changes that's going to occur within the lead nitrate, right? So there were several changes that's going to happen within the lead nitrate, right? So we'll write down our observations. First observation is you could see that a brownish color, right? Like a brownish color gas is going to yellowish brown color or brownish color. We'll mention that thing as a brownish color. So we could observe first of all a brownish color gas which is going to emit from the system or from the boiling tube upon heating lead nitrate, right? Then if you take the final residue means whatever the thing which is remained in the system, right? So the residue of the system is a reddish color substance, right? It's a reddish color substance. So a reddish color residue remained within the system after the heating process. Then we could observe that a brownish color gas is going to emit from the system. So those are the two main observations that we took from this experiment. So we'll write down our experiments, we'll write down our observations, my dear children, right? So the first one is right, brownish color gas. So brownish color gas emits. Brownish color gas emits, right? The first observation. A reddish substance was found in the end. So in the end we can find a reddish color substance which is getting remained within the boiling tube. Reddish color substance. So these are our main observations. Number one is brownish color gas emits, right? Brownish color gas is going to emit from the system. And in the second observation, you could observe a reddish color substance which is remained within the boiling tube, right? So here you can see that earlier the lead nitrate was white in color and it is kind of a powder, right? A kind of a salt kind of a powder, right? A crystal. So when I am going to heat this, right? When I am going to heat this, you could see that when I am going to heat this system, you could see that there are two new substances which is getting created within the system. The two new substances were, the first one was a brownish color gas. And the second one is a reddish color residue, or else a substance that is remained within the boiling tube. Okay. So here you can see that, right? Here you can see that lead nitrate has changed its composition to form new substances. So finally we can conclude that upon heating lead nitrate, a chemical change has occurred. How can you see that? It's because that lead nitrate has now undergone through series of changes to form new substances. The composition of lead nitrate has got changed right now. If it is not, then the original lead nitrate should be there in the system, right? But you could clearly observe that original was in white color powder, but now it has got a reddish color powder, right? Reddish color substance. So initial substances now changed into new substances. So we can finally conclude that in this situation, a chemical reaction or else a chemical change has got occurred in the system. So we can write like this, our conclusion. Lead nitrate has subjected to a chemical change. As there are new substances in the system. Right? So lead nitrate has subjected to a chemical change as there are new substances in the system. So there were new substances in the system. You can see in here there are two new substances, brownish color gas and a reddish color substance. So there are two new substances from lead nitrate which has got created. Okay, so we can say that finally lead nitrate has subjected to a chemical change as there are new substances in the system, right? So here you can clearly observe during the formation of new substances, we can say that sometimes a gas can be evolved. A gas can evolve. A smoke can evolve. Smoke means also a type of a gas. So a gas can evolve during a chemical change, right? Forming as gas is a new substance. So when creation or upon creation of new substance, these new substances could be a gas, right? So here we can conclude that finally, during a chemical change, upon forming new substances, gases may evolve, right? Gases may evolve. Okay then, so my dear children, this is the experiment, the first experiment regarding the chemical changes. Now let's move on with another activity, another type of an activity to observe the nature of chemical changes, right? So the second activity to observe about chemical changes. So you are given with these materials. Let's identify the materials given in here. So you will be needing these materials in conducting the activity. First of all, you will be needing some copper sulfate. This is copper sulfate, a type of a salt that we can find in our laboratory. A blue color salt, light blue color. You can dissolve copper sulfate in water to make into a solution, right? It's also a blue color solution, copper sulfate. So this is copper sulfate. Copper sulfate. We need some amount of copper sulfate. Then a clean, right? A clean iron nail, right? This is an iron nail. Clean iron nail. If it is not clean, then you can use a sandpaper and you can wipe it off the surface to make it into a clean iron nail, right? Then we'll be needing a boiling tube. And especially within this activity, to check whether there is any kind of a temperature difference, right? To measure out the temperature, initial temperature, the final temperature. To measure out the temperature, we'll be needing a thermometer. Right? Thermometer. We'll be needing a thermometer to measure the initial temperature and the final temperature. Final temperature means here, even after doing the experiment, right? At the end, we are going to check the temperature of the system. Okay? So to measure and check the temperature of the system, we'll be needing a thermometer. So these are the materials that we need. So how to conduct the activity then? Conduction is really simple. What you have to do here, you take copper sulfate and make a blue color solution by adding water to this boiling tube. It's really simple. You add some water to copper sulfate and make a solution of copper sulfate to the boiling tube. Then we have to insert the clean iron nail into the system. When I'm going to insert the iron nail, I'm going to check the temperature of the system and record it down, right? I'm going to take the temperature of the initial temperature of the system, then I'm going to record it down. Then I'm going to leave it for some time and observe after. Then after observing, I'm going to take the changes which are going to happen within the system. I'm going to check whether a color change is happened or not. Whether a color change has happened or not within the copper sulfate solution. You know that copper sulfate solution has a blue color nature. So first of all, I'm going to check whether a color change has occurred or not. Right? Whether a color change has occurred or not. That's the first and foremost thing to do. Then I'm going to check what has happened with the iron nail. What has happened with the surface of the iron nail? Is there any kind of different substances which are formed here? Okay. Then after that, I'm going to insert the thermometer once again to the system and check the final temperature. Right? So those are the things, observations that you need to take during this experiment. Right? So before we are going to make our observations, so let's write down the method of doing the experiment. So the method, right? Method is really simple. What you have to do? First of all, make a blue color solution of copper sulfate make a blue color solution of copper sulfate. Make a blue color copper solution of copper sulfate into the using the boiling tube. Using the boiling tube. Okay, so make a blue color solution of copper sulfate using the boiling tube. In the next step, insert the iron nail into the boiling tube. Record the initial temperature. Record the initial temperature of the system. Right, insert the iron nail into the boiling tube. Record the initial temperature of the system. You have to record the initial temperature by using the thermometer, right? Okay, then check the system after some time. After some time, record the final temperature right? So this is the way of doing the experiment. Then it's really simple. What you have to do, first of all, make a blue color solution of copper sulfate using the boiling tube. You have to use the boiling tube and put some copper sulfate into it, add some water and make a blue color solution. Then insert the iron nail into the boiling tube. Then record the initial temperature of the system. We have to insert the iron nail into that boiling tube, and by using the thermometer we have to get a reading, initial reading, right, for the starting temperature. Then finally we have to check the system after some time and we have to record the final temperature, right? So this is the way of doing the experiment. So we'll head on to the lab and we'll conduct the activity, and let's see what's going to happen when you are going to insert an iron nail into a copper sulfate solution. Right, my dear children, now let's conduct this activity. Let's conduct this activity where we are going to use copper sulfate, right? And we're going to make a solution of copper sulfate, and I'm going to add a piece of iron nail in here, right, to see whether there is a chemical change or not. And if there is a chemical change, what kind of an evidence is being provided with the experiment if there is a chemical change, right? So I'm going to conduct the activity and we'll see like what kind of a change is going to occur. What are the new substances which is getting created within the system. So by using the new substances, we can say that a chemical reaction or a chemical change has occurred. So first of all, I'm going to add some amount of copper sulfate. So this is copper sulfate. So copper sulfate is a blue color crystal powder, and also you can observe, or if you want, you can get copper sulfur as a crystalline solid, like a piece of rock, a blue color, right? So this is copper sulfate. To dissolve these copper sulfate quite easily, I have taken in the powdered form. So now I'm going to add this copper sulfate into the boiling tube. right? I'm going to add. Then using a wash bottle, let's add some water. And now let's mix it well. So let us add some more water. Right, so I have prepared my copper sulfate solution here. It has a light blue color. You can see it very clearly. It has a light blue color. Right. So what I'm going to do is, now I'm going to place it over here. And we will measure the temperature of the system or in the copper sulfate solution here. So we need this temperature, the measurement of temperature, in order to check whether there is a heat change or whether there is a temperature change in the system during a chemical change or not. So to observe it quite well, I'm going to use this thermometer and I'm going to measure the initial temperature of the copper sulfate solution. So I have the thermometer with me. So let's insert the thermometer and we'll get a reading. Right. So here the initial temperature of the copper sulfate solution is about 30 degrees of Celsius. Right. It's 30 degrees of Celsius. The initial temperature, you can see it clearly in here right now. See? The initial temperature is 30 degrees of Celsius. Right, now I'm going to insert the iron nail into this container. I have a cleaned iron nail, right? So I'm going to insert this cleaned iron nail into the system like this, right? Now we'll leave it some time and observe what kind of a change is going to occur in this system. Right, my dear children. Now you can observe there is a difference in the color. See, there is a difference in the color. The color has somewhat lightened up. Right? In the earlier case, initially it had some kind of a blue color. Now the blue color has reduced. Now I'm going to insert the thermometer and we'll observe how much is the temperature in it now. Right, now you can clearly observe the temperature has rose up to 5 degrees. Up to 5 degrees means now the temperature is at 35 degrees of Celsius. Earlier it was 30 degrees of Celsius. Now after the reaction, now the temperature is at 35 degrees of Celsius. 35 degrees of Celsius. So let's take the iron nail. I'm going to keep the thermometer away. And now we'll take the iron nail out and we'll see whether we can observe any change in the iron nail. So I'm going to pour out the water. Right, let's see whether there is any change in the iron nail. Right, now in the earlier case, my dear children, this iron nail was a very cleaned iron nail. There wasn't any substance. Now here you can observe when I'm going to scratch this one down by using this glass rod, we can see there are some substance. This substance is like a powder. See? There is a substance around the iron nail and it's like a powder. See? You can see that powder in here within the liquid. Within the copper sulfate solution, you can observe it. Right. So I'm going to take it to my hand. Let's see. See that powder? See? Now you can observe the iron nail, that shine iron nail within that within this brown color powder. It's a brown color powder. Right? I'm going to use a tissue and I'll show you this powder. See? So it has a brown color. Right? It has a brown color stain. Right? So this powder is copper. Right? In the copper sulfate solution, when I'm going to add the iron nail, the copper is going to deposit, or copper is going to precipitate. These substances, these copper substances, these are not getting mixed with the solution. I mean the liquid. Right? So these substances are getting remained within the solution after the chemical change or the chemical reaction. So these substances which are getting remained within a solution after a chemical reaction is called a precipitation. This is called as a precipitation. So here we can say that new substances have been created. It's because that in the earlier case, when we are dissolving only the copper sulfate, there was no any substance like this. But after adding the iron nail into the system, we can see these brown color stains around the iron nail. And also you could observe the color has reduced. The color of the system also has reduced. And once again, the temperature of the system also rose from 30 degrees to 35 degrees of Celsius. So here we can provide three evidences. Right? Those three evidences are, during the creation of a new substance, we can see a precipitation. So a precipitation means a solid substance like a powder that can be observed in a solution. This solid substance or this powder is suspended on the solution without going into the solution, without dissolving on the solution. So that kind of a thing is called a precipitation. So if a precipitation can be observed in a certain chemical reaction or in a certain chemical change, or in any kind of a change or in any kind of a reaction, if a certain precipitation can be observed after the change, then that change is a chemical change because new substances have been created here. And if the temperature is going to increase, or else vice versa, means if the temperature is going to decrease, or increase, in that kind of a scenario also we can say that a chemical change has occurred in a system. And the third proof is that if the complexion or the color of a system is going to change during some sort of a reaction, or else in some sort of a change. So in that case also we can say that this reaction is a chemical reaction, or this change is a chemical change. So we can provide three evidences by doing this experiment. Those three evidences are, in a chemical change, a precipitation may occur, a temperature change could be observed, change in complexion or change in color can also be observed if there is a chemical reaction. Right. So we'll continue with our lesson once again. Right, my dear children. So we conducted the activity at the lab. You could observe several changes, right? That's going to happen within the system when you are going to insert an iron nail, right, into that blue color solution of copper sulfate. The first and foremost thing here is that you could see the color of copper sulfate solution is going to reduce with the time. okay, color of the copper sulfate solution, the blue color of the copper sulfate solution has got reduced. The color is going to reduce. The second observation is that when I am going to observe the surface of the iron nail, a brownish color substance could be observed, right? A brownish color substance can be observed on the iron nail. And also within the boiling tube also I could observe some amount of brownish color substance, right? Brownish color substance could be observed within the boiling tube as well, within the solution, right? So these substances, right, which are depositing on a certain liquid is called as a precipitate. It's referred as a precipitate. Precipitate is a kind of a solid substance that's not getting into a solution, that is not mixing with a solution. It's not getting dissolved within the solution. Kind of a solid substance which is getting remained or retained within a liquid, within a liquid. So this is called as a precipitate. A precipitate. So here we could observe a brownish color precipitate. A brownish color. Brown color precipitate, right? We could observe a brown color precipitate within the system. So when I am going to observe the iron nail also, the same brownish color nature of substance could be observed on the iron nail as well. And the third main observation is that the blue color of the solution has got reduced. We measured the final temperature by inserting the thermometer, dear children. And you could observe that the temperature of the system has got increased, right? The temperature of the system has got increased by several degrees. So there are several observations. We'll write down one by one then, okay? Number 1. Blue color of the solution, blue color of the solution reduce. Blue color of the solution reduces. Number 2, brownish substance can be observed on iron nail, comma, in the solution. Right? Brownish substance can be observed on iron nail plus and in the solution as well. Number 3, temperature has increased. Temperature has increased, right? So these are the main observations that we can take from the experiment, right? First one is blue color of the solution reduces. Blue color of the solution reduces. Second one, brownish substance can be observed on the iron nail and in the solution as well. Then in the third one, temperature has increased in the system. Temperature in the system has got increased. So these are the three main observations that we can take from this experiment, my dear children, right? So based on these observations, right, based on these observations, we can say that during a chemical change, you know that this is a chemical change. How can you say that? Because new substances has got created in the system. So this is a type of a chemical change, right? When you add iron nail into a copper sulfate solution, right, a chemical change has got occurred. So these are the observations which corresponds to show that there is a chemical change within the system. When you check the color of the solution, if the color is going to change, the color is changing or the color is deviating from the original state, it's because new substances are getting created within the system. New substances are getting created. If new substances are getting created, then we can say that if the original color is somewhat blue, then the color will get diminished, or some kind of a different color will occur, right? So if there is a color change within the system, new substances has got created. If new substances has got created, then it is a chemical change. Then the second observation, if a precipitate is going to occur, right? So these substances which are depositing within a liquid without going into a solution, without dissolving, right? Some kind of a substance, a solid substance is going to deposit within a solution. So if there is a solid substance, right, which is getting deposited, then it is also a type of a evidence, right, to show that there are new substances. So this brownish substance is a good example to show that there is a chemical reaction between the things in here, right? So chemical change has got occurred in here. We can say that there is a chemical change, right? We can say that there is a chemical change by using the second observation. If new substances are getting created, we know that it's a type of a chemical change. So if a precipitate is going to come within the system, then also we can say that there is a chemical change. Then in the third one, if the temperature is going to rise or fall, both are correct, right? If the temperature is going to rise or fall, temperature is going to change. If the temperature is going to change, in that situation also we can say that the change in temperature is a result of a chemical change, right? So therefore, these are the solid evidences that we can provide to show that there is a chemical reaction within the system. So finally, we can conclude that new substances has got created within the system in this experiment. So therefore, this system undergoes in a chemical reaction or else a chemical change. Right? We'll write down our conclusion then. New substances are created. New substances are created within the system. Therefore, system has undergo in a system has undergone a chemical change. Right, so new substances are created within the system, therefore system has undergone a chemical change. This is the final conclusion that we can take from the experiment, right? So my dear children, if new color is going to create within the system, we can say that a chemical change has happened. If a new color substance has got created, we refer this thing as a precipitate. If a precipitate is going to occur, then a chemical change has occurred. If there is a rise or fall in temperature within the system, then there is a chemical change. So these are the three main evidences that we can take from this experiment. So we'll move on to discuss another activity, another experiment to discuss the nature of chemical changes. Third activity, to study the nature of chemical changes. So you'll be needing these materials. Once again, here you can observe there is a solution, a blue color solution. Like in the earlier case, you could remember the blue color solution was copper sulfate. So once again, you'll be needing copper sulfate solution. Copper sulfate solution. Then after that, we'll be needing some amount of sodium hydroxide solution. Sodium hydroxide solution, my dear children. It's a kind of a base, a type of a base, a basic substance that we can find in our laboratory. It is available as pebbles or else powder. You can dissolve it in water to make into a colorless solution like this, right? Sodium hydroxide solution. So you'll be needing sodium hydroxide. Sodium hydroxide solution. Then to mix these two solutions each other, we'll be needing a boiling tube. Right, a boiling tube. So we'll be observing here in this chemical change by adding copper sulfate with sodium hydroxide. We'll be observing what kind of a thing is going to happen, right? What sort of a thing is going to happen within the system. Okay, so let's see how to conduct the activity. Okay, it's really simple to do this thing. What you have to do, you just mix the two solutions together within the boiling tube. That's it, and observe what's going to happen. So we'll write down the method then. Method is simple. Take the boiling tube and mix the two. Mix two solutions take the boiling tube and mix two solutions and observe the changes, right? It's really simple. What you have to do, you have to take the boiling tube and mix the two solutions, right? You have to mix the two solutions, sodium hydroxide solution and the copper sulfate solution together, then we have to observe the changes within the system, right? So it's really simple. So let's head on to lab and we'll mix these two solutions together and let's see what are our observations. Right, my dear children, now let's see this experiment where we are going to mix this copper sulfate solution, some amount of copper sulfate solution with sodium hydroxide solution, right? So I'm going to mix these two solutions and to observe what kind of a change is going to occur when I'm going to add these two solutions separately. So let's take a boiling tube and I'm going to add some amount of copper sulfate right, my dear children. Now this is my copper sulfate solution. Now what I'm going to do is I'm going to add this sodium hydroxide solution into the copper sulfate solution, but I'm not just going to pour it in here. To get somewhat clearer observations, I'm going to use a small bit of a dropper and I'll use the dropper to put this sodium hydroxide into the copper sulfate solution. So I'll use a dropper, right? So this is the dropper. So I'll use the dropper and we'll add drop by drop to check the observations. Check the observations clearly. You can see there is a change in complexion. There is a change in color. See the top part, this part, the color of this part is somewhat darker than the color at below. So I'll add some more. Now you can see it clearly, right? It's very clear to us. There is a light blue color, not that much darker blue, but somewhat of a light blue color precipitation. So precipitation means here you can observe, see, this is a type of a solid. It's not getting mixed. See, type of a solid. You can see it on the wall also. A type of a solid that not getting mixed or not getting dissolved within the solution. It not getting mixed with the solution because it is a precipitation. So when adding sodium hydroxide to a copper sulfate solution, we can observe a light blue color precipitation. So like in the previous activity, here a precipitation has occurred. So if a precipitation is going to occur, means that this change or this reaction is a chemical reaction or else a chemical change. Right, my dear children. So we conducted the activity at our lab and you could observe that when I'm going to add sodium hydroxide solution to the copper sulfate solution, a blue color precipitate could be observed. A blue color precipitate. A precipitation means, once again, it's a kind of a solid substance, not 100% kind of a solid substance, but it is a type of a solid substance like a powder that can be observed when you are mixing two or more solutions together, right? When you are going to mix two solutions, like in the earlier case, some kind of a powdery dust could be observed within the system. So that powdery dust is the one which is referred as the precipitate. So here a blue color precipitate could be observed within the system when I'm going to insert, right? When I'm going to insert sodium hydroxide to copper sulfate solution. So we'll write down our observation. Light blue color. light blue color precipitate. Right, light blue color precipitate. Precipitate means that dust or that kind of particles which is going to occur within the system. So a light blue color precipitate is given when mixing solutions together. Right, when mixing solutions together, we could observe a light blue color precipitate. Right, so light blue color precipitate is given when mixing solutions together. So what is the conclusion from this activity then? What is the final conclusion that we can come up with this activity? Here we mixed two liquid solutions, right? We mixed two liquids together, and during the process of mixing of two liquids, you could observe some kind of a powdery solid substance is going to deposit within the system. In earlier case, there was no such substance. Means that here also new substances has got created from the initial substances, and this new substance is also referred as a precipitate, a solid color, a solid substance, right, that's not going into a solution, So my dear children, within this activity also we can see that new substances has got created from the initial substances. Means this system has undergone a chemical change. So if a precipitate is going to occur within a system when you are mixing two liquids, right, out of the liquid a solid precipitate is going to come when you are mixing these things together. So new substances has got created in that kind of a situation. So occurrence of a precipitate is a good evidence to show that there is a chemical change. So my dear children, you can finally write down the conclusion like this. The system has undergo in a chemical change as there are new substances. Right, so the system has undergo in a chemical change as there are new substances. So what is the new substance? That blue color precipitate is our new substance. We mix two liquids together, and when we are mixing these two liquids, a precipitate is going to come. So it's a new substance. So thereby we can say that this system has undergone a chemical change. Right, my dear children. So in these three activities, we discussed several things, several observations that we can observe during a chemical change. Let's carry out another activity, another experiment, and see whether there are any different observations during a chemical change. Right, so we'll head on to see our next experiment then. So in this activity, the fourth activity regarding the nature of chemical changes. So fourth activity, you are given with several materials. Let's identify what are the materials here. First of all, within this activity, to conduct this activity, you will be needing an acid. This is hydrochloric acid. Hydrochloric acid. Hydrochloric acid is a type of a strong acid that we can find in our laboratory. Normally, if you take hydrochloric acid, in our stomach also there is some amount of hydrochloric acid. Not that much as strong as these hydrochloric acid which can be found in our laboratory, but up to a certain level that is also somewhat strong. Hydrochloric acid helps to digest food within our stomach. So our stomach also has some amount of an acidic level, right? Some amount of an acidic level. That's why when you're starving, when you're not eating food, you may feel a pain. It's because that when this hydrochloric acid is going to gather in your stomach, and if there is no food in it, right, your tissues, interior tissues and cell layers are going to deteriorate gradually due to hydrochloric acid. So this special condition is also called as gastritis, right? So if the gastritis condition is going to occur for a longer time period, then the wounds may also occur in your stomach, right? So hydrochloric acid is a substance that is found in your stomach as well, right? But not that much strong as the ones which we can find in our laboratory. In our laboratory, we have much stronger acids, right? Hydrochloric acid is also much stronger, right? Very much stronger. So how to reduce the strength of an acid? By adding water, my dear children, we can reduce the strength of it. Okay, so in our stomach also there is plenty of water. So thereby the strength of the acid contained within our stomach has a less powerful acid, right? But in our laboratory, they have been prepared in special kind of situations now, right? So the concentration or the amount of acid particles is very high and very less amount of water is found, right? So when we are dealing with hydrochloric acid in our laboratory, first of all, we have to add some water and we have to dilute it. Diluting means reducing the strength of the acid. Okay, we have to take a sample of hydrochloric acid from the lab, from the bottle, and we have to insert it into the boiling tube or to the test tube. Then we have to add some water to reduce the strength of it, to dilute it. Okay, so we'll be needing hydrochloric acid. Some description about hydrochloric acid for you guys then. Okay, so the first thing is hydrochloric acid, some amount of diluted hydrochloric acid. To dilute it, you just add water. Then this is zinc. This is zinc, right? So we'll be needing zinc pieces. You can cut these things by using a pair of scissors into smaller pieces, right? Sometimes in the lab there are zinc granules as well. Granules means like pieces, small bit of pieces, zinc granules. So however, you'll be needing pieces of zinc as the next material. Then number 3, to mix these things together, we'll be needing a boiling tube. Third one, boiling tube. Okay, so these are the materials that you need: hydrochloric acid, zinc pieces, and a boiling tube to mix these things. Right, now let's see what is the method in conducting the activity. So the method Method is really simple. You have to take those small pieces of zinc and take the sample of hydrochloric acid to the boiling tube. Then you have to mix those two together and observe what's going to happen. Right? You have to observe what's going to happen. So we'll write it down. Add the pieces of zinc pieces of zinc to the boiling tube. Add some diluted. Diluted means, I told you in the earlier case also, we have to add some water and we have to minimize the strength of hydrochloric acid. Diluted hydrochloric acid, right? We need to minimize the strength of it. Okay, otherwise it would be a more powerful chemical change or chemical reaction, right? So therefore, to minimize the strength of it, we have to add some water. So that process where the water is being added is referred as diluting, right? So we have to get diluted hydrochloric acid in this process. So add some diluted hydrochloric acid to the boiling tube. And observe. Right. So add the pieces of zinc to the boiling tube. Then we have to add some diluted hydrochloric acid to the boiling tube, and we need to observe what's going to happen within the system, right? So this is the way of doing the experiment. So my dear children, let's head on to the lab and we'll add some zinc pieces into this dilute hydrochloric solution, and let's see what kind of an observation that we can take from this experiment, right? And let's see whether new substances are going to create within this system and whether this change is a chemical change or else a physical change. Right, my dear children, now this is our next experiment to observe what are the evidences that we can provide during a chemical change. So here I have a zinc plate. This is zinc. Zinc is a type of a metal. So now I have separated a small piece of a zinc. See, a small piece of zinc, and now in my left hand side on the beaker with me I have somewhat diluted sulfuric acid. Okay, so this is diluted sulfuric acid and this is the piece of zinc. Now what I'm going to do is I'm going to add this zinc piece into the diluted sulfuric acid. So we'll see what are the observations that we can get from the experiment. So to get the observations more clear, I'm going to use a boiling tube. So I'll add some sulfuric acid. Then gently we'll add the zinc and let's see what are the observations. Right, my dear children, now after passing few seconds, you can observe the system is evaporating gas bubbles much faster. See? So the system is evaporating gas bubbles much faster right now. You can observe it very clearly. So, see, my dear children, to get observations more clearly, I am going to use a black color background. See, so when I am using this black color background, you can observe the gas bubbles very clearly. Now the gas which is getting emitted in this situation is hydrogen gas, right? So this is another type of an evidence. Here we can say that new substances has got created. New substance has got created and that new substance is hydrogen gas. So in the next grades we'll observe how to identify this hydrogen gas, but you could clearly observe that some amount of gas bubbles are going to emit in this system. So means that we can say that in this system we can conclude new substances has got created. So the evidence that we can provide in this system is that evolution of gas bubbles or emission of a gas is going to occur in a system when mixing two substances or two or more substances, can be more substances. So when mixing two or more substances, if an emission of gas is going to occur, then within that system a chemical change has occurred. That's why the gases are going to emit. So emission of gas is a new substance or it is a new material. So here this experiment shows that formation of gas bubbles and formation of gas bubbles conclude that this system undergoes in a chemical reaction. Right, so we'll head on to the classroom and we'll identify what are the changes or what are the new things, what are the evidences that we can provide if there is a chemical reaction. My dear children, so when I was conducting the activity, you could observe that some kind of a gas bubble, some kind of gas bubbles are going to evolve from the system, right? Some kind of gas bubble is going to evolve from the system, and after some time, gradually pieces of zinc is going to dissolve within the system. You're going to dissolve within the hydrochloric acid, right? So our observation was quite simple. Hydrochloric zinc pieces is going to dissolve within the hydrochloric acid and a new gas bubbles, right? A new substance, new gas bubbles are going to evolve from the system. So this is also a good example to show that there is a chemical change. When you are adding two different substances together, if a gas is going to emit, if gas bubbles are going to emit, then we can say that the system has undergone in a chemical reaction or chemical change. How come? It's because that formation of gas bubbles when you are mixing two different substances together, right, is also a creation of new substance. So my dear children, you can finally say that within this system also there is a chemical change. How can you support my idea? Because the formation of gas bubbles proves it. In the earlier case, there was no gases. There was a liquid plus some solid substances. So when you add these two, together, gas bubbles are going to evolve. Means that new substances has got created. So evolution of gas bubbles is also a good example to show that there is a chemical change. Right, so we'll write down our observation and conclusion then. So our observation is quite simple. zinc pieces dissolved in the solution. Gas bubbles are evolved. Gas bubbles are evolved from the system, right? Gas bubbles are evolved from the system, and the earlier one is zinc is going to dissolve within the solution. So these are the two main observations that we can take. So here also you can see that new substances has got created. What is the new substance? The gas bubbles. So finally we can say that when adding zinc to hydrochloric acid, new substances are formed. New substances are formed. Therefore, it is a chemical reaction. Chemical reaction, or else we can say a chemical change. So when adding zinc to hydrochloric acid, new substances are formed. Therefore, it is a chemical change. This is the final conclusion that we can take from the experiment. So my dear children, we discussed 4 different experiments to identify the nature of chemical changes. We took several observations when we are doing these things, right? Now we are about to discuss what are those observations that we can identify during a chemical change. By using these observations, how to provide a solid evidence to show that there is a chemical change within a system. So let's summarize our observations, right? And let's see what kind of a thing is going to, what kind of things are going to occur within a chemical change. So let's summarize all of these together. So there were 4 experiments. Number 1, heating lead nitrate. That's the reaction. Actually, reaction means the change. I told you that chemical changes are also referred as chemical reactions, right? Chemical changes are also referred as chemical reactions. So chemical reactions or chemical changes, right? So the chemical reaction or the chemical change, the first one is heating lead nitrate. So what are our observations? Formation of a red powder, evolution of brown colored gas. Red color powder was there and a brown color gas has got emitted, right? Second one, putting an iron nail into a copper sulfate solution, right? So the observations, blue color decreases, reddish brown substance deposited on the nail and at the bottom of the solution. That's the second activity and the second observation. Third one, adding copper sulfate solution to sodium hydroxide solution. Copper sulfate to sodium hydroxide. Observations, dark blue solution is formed. Dark blue, right? dark blue solution. Solution, actually it is a precipitate. A blue color precipitate is given. When further added, light blue solid is formed. Right? When you add in even more, right, a light blue solid is going to create. That solid is referred as a precipitate. Precipitate. Then the final one, when you add in zinc granules to hydrochloric acid, zinc pieces, granules means pieces. Zinc dissolves and a gas is liberated. Zinc is going to dissolve within the system and a gas is going to liberate. So these are the 4 types of activities that we discussed under the chemical changes. See, these are the observations. In each of these cases, you could see that new substances has got created. New substances has got created from initial substances. In all of these cases, you can observe it. Formation of a red powder, new substance. Evolution of brown color gas, new substance. Blue color decreases, new substance. Reddish brown substance deposit on the nail and at the bottom, new substance. Dark blue solution is formed. Finally, a precipitate could be observed. Precipitate, a new substance. Evolution of gas bubbles, new substance. So in each of these cases, you could observe there are new substances. If there are new substances, my dear children, then there are solid evidences to prove that there are new substances. So in a chemical change, there are some certain things which we could observe. There are some certain things, certain special observations that we can see in a chemical change to support that reaction, that change is a chemical change, right? Here new substances has got created. So upon formation of new substances, some kind of a different observation should be there. So now let's see what are those observations. So based on the observations made regard to the chemical reactions, following can be given as evidences in support of the fact that a chemical reaction has taken place in the above activities. So in the above activities, we discussed that chemical changes has got occurred. So these are the points, special points that we can see during a chemical change. At least one of these observations should be there if there is a chemical change. At least one of the observations should be there if a chemical change is going to occur within a system. So what are these observations? Number 1, evolution of gases. Evolution of gases means smoke is also correct. Evolution of smoke, evolution of gas bubbles, like in the earlier case when we are adding zinc granules to the hydrochloric acid, you could observe that gas bubbles are going to occur. When you are burning piece of paper, you could see that smoke is going to occur. So that in those kind of cases, evolution of gases or evolution of a smoke can be observed. So if there is evolution of gas or else a smoke, then my dear children, that system has gone in a chemical change. Next one, change in color, right? Change in color. So in the earlier activity, when we are adding iron nail to that copper sulfate solution, the blue color of the copper sulfate solution reduces. So decrease in color or increase in color or change into a different color. Whatever the situation, if the color is going to change within the system after adding several substances together, then that system has undergone a chemical change. So change in complexion or change in color is also a good example to show a chemical change. Number 3, change in temperature. Now change in temperature means, especially in here, exchange of heat. Means that if the environment temperature is getting absorbed into the system like this. Now this is the system. Temperature is going to absorb. Temperature means actually heat is going to absorb. If the system or the solution or whatever the thing which is contained within the container is going to absorb heat from the external environment, right? From the external environment, it's going to absorb heat, right? In that case, now listen to me carefully on this thing. My dear children, now this is the container. We'll assume that this container is at 27 degrees of Celsius. So when heat is going to absorb into the system, this 27 degrees of Celsius will definitely drop down. Why it is going to drop down? It's because that when temperature is going to absorbed by the system, right, the temperature of the container will get reduced, right? So when you are mixing certain thing, if the temperature is going to reduce, here the heat has been absorbed into the system or into these solutions, or into these things are referred as reactants, right? The initial substances in a chemical change are called as reactants. So to the reactants, if the heat has absorbed, then the temperature is going to drop down. Second case, like this way, there are several substances. Now during the chemical change, these substances are going to emit or exit heat. Okay, so heat is given out. So if heat is given out, then the container is going to increase the temperature. Let's assume that when I'm going to mix these substances within the system together, the initial temperature was 27 degrees of Celsius. So after I'm going to add these substances, we shake it for some time so that they will mix each other. Chemical change is going to occur, and within this chemical change, heat is going to emit, right? During the chemical change, the substances are going to emit heat. In that process, the container's temperature will definitely increase. It will show like 30 degrees of Celsius. Here it will show like 25 degrees of Celsius. This is just for an example, right? This is just for an example, not the actual values. I have imagined that this kind of a thing is going to happen, right? So exchange of heat. Exchange means either releasing or absorbing, right? If the heat is absorbed externally into the system, temperature drops. If the heat is going to evolve by the reactants out to the environment, then the temperature is going to increase, right? So this is how it actually works. But in simple case, we'll remind it like this way. So simple. If there is a chemical change, then we can observe just a change in temperature. That's it, right? If there is a chemical change, we can observe a change in temperature, right? It can be either absorbing heat or releasing heat. No problem with that. However, the temperature is going to change. Initial temperature is going to differ with the final temperature. Either it is being reduced or else increased. No matter in the case, right? If the temperature is going to change, then the system has undergone a chemical reaction. Then the next one, formation of precipitates. formation of precipitates. Precipitates are the solid substances or those powdery like things that can be observed within a solution, right? So initially there was no, right? Initially there was no there was no substances like solid substances within the solution, but after mixing solutions together you can observe like a powdery solid substance. That thing is referred as a precipitate, right? So precipitates are not getting dissolved within the solutions. So precipitate, formation of a precipitate. Then the next one, production of sound or light, production of energy, sound energy, light energy, heat energy, right? Like that way, if a type of an energy is given out, right? If a type of an energy is given out from the system, in that case also we can say that a chemical change has occurred within the system, right? Like when you are firing up a cracker, right? That cracker is going to burn up, giving out a huge sound, and sparks are going to come. So all of these examples reflects a type of an energy, sound, light, heat, and so on. So if a type of an energy is given out from the system, then that system has undergone a chemical change. Then the next one, production of an odor, a smell, right? Production of an odor or else giving out a smell. Smell change is also a good example to show that there is a chemical change, my dear children. So these are the main things, main evidences that we can provide during a chemical change. If a chemical change has occurred in a system, at least one of these observations should be there. At least one of these observations should be there, right? So during a chemical reaction, right? During a chemical reaction, you could observe these special things within a system, right, my dear children? So let's head on to see what are our next things in the lesson. So you are given with special points here. What is a chemical change? The formation of new substance having a different composition or several new substances by one or more substances undergoing change is known as a chemical change or else a chemical reaction. So we already know what do you mean by this thing. Here in simple, new substances are getting created from the initial substances by changing their composition, right? So chemical change is a type of a change that occur in a system due to formation of new substances by rearranging or by changing the composition of initial substances. The substances that get subjected to change during a chemical reaction are called reactants. Reactants. This is really important, my dear children. The initial substances that we are going to introduce into the system are called as reactants. Reactants, right? During a chemical change, the initial substances that we are going to enter the system are called as reactants. Initial substances, starting substances are reactants. Reactants. The new substances formed by a chemical reactions, right? New substances formed by a chemical reactions are referred to as products. The new substances are called as products, right? After chemical reactions, the new substances which are created are called as products. new substances are called as products. So if you take a certain type of a chemical reaction, initial substances means reactants are getting converted to products. Right? Initial substances or reactants are getting converted into products. Okay? This is what happens in a chemical change. Initial substances are called reactants. The new substances which are getting created after chemical reactions are called as products. So during a chemical reaction, reactants are getting converted to products. Reactants are the substances which is subjected to change during a chemical change. The initial substances, first and foremost substances that we are going to enter into the system. The new substances are the ones which are referred as products. So products are created after by chemical reactions. Right? Okay. So reactants and products. Reactants are the initial substances. Products are the new substances created after the chemical reaction. Right then. So in any chemical reaction, you know that reactants are getting converted to products. Right? In any kind of a chemical reaction, reactants are getting converted into products. So during the burning of magnesium, which is a metal with a silvery luster, upon heating it combines with oxygen in air and forms a white powder. That powder is known as magnesium oxide. You could remember I explained the burning process of magnesium earlier. Right? I explained what is going to happen when you are burning piece of magnesium in air. It's going to combine with oxygen gas in the atmosphere and it's going to create a white color powder. So that powder is called magnesium oxide. Right? That white color powder is called magnesium oxide. So the initially, right, in the system there was only magnesium and oxygen was in our atmosphere. Right? So when these two substances are going to interact each other, the new substance which is called magnesium oxide has got created. Right? So my dear children, magnesium and oxygen are the initial, first and foremost substances that we enter to the system. Okay? By the interaction, the magnesium oxide which created is the new product. So here, see, you can write the reactants of this reaction are reactants, the initial substances, magnesium, that is a metal that has a silvery luster, right? And when you are going to heat it down, heating means combining with oxygen, right? So there was oxygen in the system as well initially. Those things are two different substances, right? Like this. So magnesium, then oxygen. Oxygen gas. These are the two different substances contained within the system, right? Now, oxygen gas is going to interact with magnesium and the products which are getting created are magnesium oxide, right? Magnesium oxide. It's like this, my dear children. Let's imagine magnesium is a type of a material which made up with A. Like in the paper case, can you remember when I was tearing that paper, I drew the same figure. Can you remember? Right? So this is magnesium made up with A substances or A particles. Then there is oxygen made up with B particles, like this. Okay, this is magnesium made up with A particles. This is oxygen, right, made up with B particles here. Now when you mix these two together, A and B is going to mix together to create the new substance which is called as magnesium oxide. It's like this in simple. This is magnesium made up with only A matter or A particles. This is oxygen made up with B particles. When these two are getting interacted each other, new substances are getting created. New types of particles are getting created. How come? By the rearrangement. These things are going to rearrange, right? A is going to combine with B to create new type of a substance, magnesium oxide. So this is what is called as a chemical reaction or else a chemical change. These substances are called as reactants. These substances are called as reactants. New substances which is created are called as products. So this is how a chemical change, a chemical reaction is going to work, right? Their particle structure, particle composition is going to change, and their particles are going to rearrange like this to create new substances. So this sort of a thing is called a chemical reaction. Okay, my dear children, so I hope that you took a sound knowledge about the chemical reactions, how to provide examples for chemical reactions, what are the special observations that we can see during a chemical reaction, and what kind of a thing is going to happen when a chemical reaction is going to occur. So basically, in a chemical reaction, like I said before, what happens? Reactants are getting converted into products. Products are the new substances, reactants are the initial substances. Right, my dear children. So, let's hope that you took a good knowledge about chemical changes. Right? So, this is the nature of chemical changes. So, my dear children, I'll hope that you took a sound knowledge, and let's meet with a different chapter to discuss further things related with the lesson.